Hello, I'm glad you could join this new Tech Talk because it's going to be a really interesting one. Still with us, Bruno Putseis, and the topic of this one is active loudspeakers. I think you know a thing or two about that.
Yeah, well, it was unavoidable, as I mentioned earlier, is that the commoditization of good power amplification and good conversion and whatnot sort of draws attention to the fact that the traditional hi-fi chain has no synergy at all, and it can only have one logical final conclusion, which is that you just put the whole chain into a single box.
Yeah.
And there's some interesting observations to be made there because I was once asked by someone like well, what does an active speaker do better than a passive speaker? And well, you have to think a bit, because the meaning of active speaker is quite fluid.
Mm-hmm.
For instance, active speakers have sold forever in the studio market, and what they often were loudspeakers that could easily work with a passive filter, where the passive filter has then been taken out and replaced by a couple of separate amplifiers, and then an electronic filter that mimics mimics the frequency response of those passive filter you've just taken out. In actual fact, I've known people in the studio space who designed speakers that way. So the first thing they did is they made a passive speaker, and then right at the end they just copied the crossover curves into either an analog or a digital EQ, and that was your active loudspeaker. And if you ask me, like, why is that better? I would have serious trouble making an argument for that, because I don't think it's better at all. It sounds exactly the same. It's functionally the same thing.
Mm-hmm.
And still, you do occasionally find people selling active speakers that are constructed exactly along those lines, and sort of expecting that they are better. And I also know of friends of mine who actually sell very high-end passive loudspeakers, and they just say, well, yeah, we did the active experiment and it sounded the same. So why on earth should we complicate things? Well, no. If that is what you do, then you should not expect magic improvements. It's still the same loudspeaker.
Mm-hmm.
So we have to start looking instead at, if we make the decision to make a speaker active, what opportunities does that give us that we didn't have before?
Yeah.
As a quick sideline, because I think people might ask, well, why were so many studio monitors active then? If it didn't help, it's quite simply because people who have recording studios, they need the speaker as a tool, and they want no fuss. But they just want something that they can plug into their console and it functions.
Yeah.
So that's really the raison d'etre for putting the amplifier in there. And then if you put the amplifier in there, well, why not save some money on the crossover components and do them actively? Because a crossover cord is more expensive than an amplifier channel. So
but that's not your pinnacle active speaker then.
No, absolutely,
really.
Absolutely not. But it is basically what you if you only want the speaker as a monitor, then it's practicality and price.
Yeah.
But it does mean that you're wasting an enormous opportunity for design. Sort of first thing that I might think of is the bass part of the speaker of the speaker cabinet. So the box usually a speaker these days. If you've got a cone drive, you might have either a bass port or passive radiators on there, and you might ask yourself, why is that? Well, that is actually largely because of the compartmentalization of the chain. If the amplifier produces a flat frequency response, then the speaker itself also needs to have a flat frequency response down to the lowest lowest frequency. Yep. Now, a loudspeaker drive that has an efficient loudspeaker drive with a strong magnet in it actually doesn't allow you to tune it mechanically and acoustically such that it has a flat frequency down to a low frequency. Yep. Because I mean, this is going into acoustics a bit deep, but I think it's worth mentioning is that the basic first thing you read when you read up on acoustics, the very first formula that's in that book shows you that the sound pressure that you measure away from a point source is proportional to the second derivative of the amount of air that's being displaced by the point source. Which means that if you translate it into cone terms, is that the sound pressure level is directly proportional to the acceleration of the cone, not the position, not the speed, but the acceleration. And at high frequencies, that's actually quite nice because you connect an amplifier to a voice coil, and that generates a certain amount of current, and that current is roughly the same at all frequencies. It applies a frequency-independent force on the membrane. The membrane is largely a mass, and as a result, it'll accelerate proportional to the force. If you increase the mass, then the only thing that happens is that the efficiency of the loudspeaker goes down. Well, it's not the only thing that happens, but one of the things that happens is that the efficiency of the loudspeaker goes down. If you make the cone lighter, it's more efficient. But actually, over the entire usable mid-range bandwidth of a loudspeaker, it's always operating as a mass that you're pushing on, and which is accelerating. Which most people sort of think that mass must have something to do with bandwidth. No, it doesn't. It's purely the efficiency. Then at very, very low frequencies, what happens is, of course, the loudspeaker is mounted in a box, and it's got and the cone is suspended by a surround and by a spider in the back. So if you then apply a constant force, then essentially it'll move, and at some point it'll stop at a position which is determined by the simply by the force and the spring force of the suspension. So at very low frequencies, the cone position is directly proportional to the input signal, meaning that at that point the SPL is actually that the acoustical output actually drops off with a second order, i.e. 40 decibels per decade at the bottom end. And so what you need to do to tune a speaker is you need to make that corner between the flat part where the cone is purely a mass and you don't see the suspension, and the part where the cone is purely sitting in a stiffness controlled by the suspension. So you've got that low frequency corner, low frequency asymptote. You've got the high frequency asymptote, which is flat, ideally that is, and you've got the corner between them. And because the second order system, the best way you can make that you can make it as flat as possible down to that particular corner is to make it resonate at with a particular what they call Q factor. As Q factor is how easily it resonates, and that Q factor is for a simple speaker in a closed box should be 0.7. Square root of a half, but that actually is not attainable if you have if you have a speaker with a very strong magnet, because that strong magnet and the voice coil, which is shorted by the amplifier on the other end, is actually breaking the resonances, and you lose bass response.
Yeah,
and if you want to make it naturally flat in a sealed cabinet, you will find out that you will need very impractical parameters for the size of the box and for the loudspeaker and so on. It's actually pretty hard to do, to make a sealed box. Even so, everyone knows, of course, that a sealed box has a tighter impulse response than one with a bass port. Why is that? Well, what you do with a bass port is you create a second resonance with a higher Q than 0.7, which more or less lies on top of the one which has too low Q, and then you sort of help that corner back up, but at the expense of not being able to produce any low frequency signal at all, because at that point, because below that corner frequency, the air that is pushed forward by the cone is compensated by the air that it sucks out of the bass port.
Oh.
So you get that tiny little increase that you get, an extension that you get out of a bass port, is being paid for by that extra resonance, which sort of makes the impulse response ring out much longer than it should, and you lose and you lose some bass extension, or you lose bass below the corner frequency even more quickly than if you didn't have a port. So but that compromise, the usage of a port, is, as I said, is really only caused by the fact that we have an unprocessed audio signal, unequed audio signal being delivered directly to the loudspeaker terminals, and you somehow have to make do.
Mm-hmm.
And if you say, okay, we've got an active speaker and we've got an active crossover, so how about just making up the difference between that low frequency curve that drops off too early and the one which you want? You just make up the difference with an EQs and just bump it up a bit. Well, these days, amplifiers are very cheap, and you can actually do it, and so you do.
Okay.
Yes. So I saw you shake your head because you were wondering, is this a good idea?
Yeah.
It works fantastically well. The only limit is simply how much power the speaker can handle. Because of course, if you have a sealed box, and even more so if you say you want to make the box a bit smaller, because now if you can EQ, you don't actually need to worry about the size of the box. You can just make the box half as big and add more current. But if you make the box half as big and you want the same frequency response, you need to have twice the drive current, or 4 times the power. And at some point, you have to make a compromise.
Yeah.
But that compromise the compromise that you end up making is definitely not just flat unequalized. That's the whole. That's the whole point. So you can make a smaller box, extend the response, relying on the fact that nowadays, thanks to Class D, a big heavy power amplifier is no longer big and no longer heavy, but still powerful.
Mm-hmm.
And you get the very tight impulse response that you get from a sealed cabinet. And in fact, this is kind of has been normal practice purely in the subwoofer arena, because you know that if you buy like Velodyne subwoofer or so, one of these things, they're small affairs, and they're sealed.
Yeah,
and they have absolutely ridiculously powerful amplifiers in there and drivers that can A, move a lot of air, and B, eats a lot of power. That is exactly that thing exemplified. But if you're going active speakers, then you can say, okay, well, if that subwoofer is so ridiculously small compared to what it can do, why not just do that with the bass section of an active speaker and get the same really tight bass? So that's kind of the very first example of how making the speaker active allows you to make it smaller.
Mm-hmm.
And allows you to get, actually, objectively, a better transient response, a tighter bass.
Okay.
That's only just the bass section, and the next thing which you can also do is you can improve power handling. Because as I said, if you have a speaker with a port, below the port frequency, essentially the box is open. because whatever whatever air the woofer pushes on will find its way out through the port, meaning that frequencies below the core frequency of a ported sound system will actually cause the woofer to move too much.
Mm-hmm.
And actually the power handling of a ported speaker is not terrific unless you tune it very low, which I would recommend anyway, because if you tune it very low, also that second resonance become much less audible. So let's say if you have to do a ported cabinet, make it big enough and make it go low enough, then at least you get a benefit from the port without being immediately bitten by this power handling problem. But in an active system, well, especially if you're going to a DSP system, you actually know what signal is coming into the speaker, and you can actually work out, okay, this signal is about to make my woofer move 10 millimeters. Oh, hang on, I haven't got that much amplifier power, and the woofer won't like it either. So how about quickly, temporarily retuning the acoustical response a bit higher, just enough so that it stays within its safe limits, both for the amplifier and the woofer. And here's the thing: in a hi-fi speaker, you very often have to oversize the cabinet and the woofers and everything. Because if a woofer hits the buffers, that sounds quite bad. Mm-hmm. It really sounds like a gunshot going off when a woofer really strikes the backplate or something like that. So it's not enjoyable at all. So you have to dimension the drivers in a passive system so that no matter what happens in the expected use conditions with the recommended amplifier power and so on, that no matter what the user throws at it, it should not suddenly explosively go wrong, which is often only a tiny fraction of the time that they're listening to music. So they're listening to music, and 98% of the time the woofer isn't moving at all, and then suddenly something happens and it moves a lot, and only for that 2% of the time, so to speak, you need to make the woofer bigger. Whereas if you have an active system and you can actually look forward and temporarily retune the speaker, you can actually dimension the woofer for the remaining 98% of the time. And because let's say, case in point, the products that I design, so active speakers on the brand name Key. At hi-fi shows, I always get people saying, "How do you get so much bass out of such a small cabinet?" And I go like, "Well, a lot of amplifier power, duh." If they were clever, they would ask me, "How do you get so much bass out of such a little cone area?"
Yeah.
Because that is a real question, and that is actually answered well by simply cutting out these tiny few times when it would otherwise cause them trouble. So you can actually use more of you can use your driver much more efficiently if you allow yourself to do that. Again, not possible if you have a separate box system where none of the boxes upstream knows what's going to happen downstream.
Yep.
So that's a very, very practical one. And well, so far we've only mentioned the bass, and that in its own is interesting. But of course, you've also got a crossover filter.
Yep.
And I think well, at least a number of our listeners will be used to seeing measurements of loudspeakers in magazines, and one of the classical measurements is the step response, sometimes called the impulse response, but it's literally a step response. Mm-hmm. So it's literally like you apply a 1-volt battery to the speaker terminals, and you record on a scope what the microphone sees. Mm-hmm. That's the step response. Yeah. Right? And what you will usually find is that you have an immediate leading edge, which is when the tweeter sees that initial step upwards is that's done by the tweeter, yeah. And then it goes down again, and it goes up again, and that's when the mid range kicks in. It goes down again and goes up. That's when the woofer kicks in, and So instead of making one clean transition, that transition is actually pulled apart in time. Simply because you're using a crossover filter, or let's say simply because you're dividing the work into frequency bands and putting them together acoustically.
Yeah.
That's when that happens, and whether you physically use crossover filters or do it in some other way, it is simply the splitting in bands and the recombining that causes that problem. It is unfortunately quite fundamental because and it is fundamental particularly to low pass filters. So you have a two-way system, say, and the woofer needs a low pass filter.
Mm-hmm.
Well, what is a low pass filter? Other than like a trend detector. So you've got a signal, an audio signal, and it does like that. And the woofer should do that part, and the tweeter should do that part, right? Mm-hmm. So a low-pass filter is a trend detector. But, if you want to detect a trend, you need to be looking at the signal for a while and before you see that there is a trend, because it's only after only after some time has passed that you see, oh, hang on, it seems we really are going up now. And that simple fact means that within the passband of that low pass filter, you are always late. And whereas the tweeter, it actually reproduces the bit which is not the trend, which is the high frequency part, which it can of course start to reproduce immediately. Yeah. And then you need to design the high pass part of the filter for the tweeter such that it doesn't actually see any of the low frequency signal, because that would just burn power without making sound. Mm-hmm. And then you can combine them in such a way that all frequencies come out equally loud. So you can get a flat frequency response, as they say. But actually, the frequency response is in that case, it's only the magnitude response, but the phase response is not preserved. And if you divide the signal into three bands, low, mid, high, you've got two such low pass filters in play, and I'll send you some pictures. I think you can splice them into this talk, showing with two-way, three-way, four-way, up to five-way systems what the resulting step responses are. But I should just want to point out, I did not make these graphs to make things look worse than they are. These are actual filter designs taken from actual existing products, some of which are in my view are very well designed as passive speakers go.
Yeah.
So what can you do in an active speaker? Well, if your active speaker has only analog processing, then this is not something you can do anything about. If you have digital processing, that's different, because, as I said, that time delay is inherent. It's called group delay, by the way. That's inherent to low pass filtering. So you cannot push it back in time. You cannot line it that way. The only thing you can do is you can take the high frequency part,
move it forward,
and exactly. So delay that as well, so that it lines up again.
Yeah.
And delaying a signal, which means storing a signal and waiting a bit and then replaying it. Well, that's something digital is perfect at.
Buffering is...
Yeah, and of course you don't literally, it's not just literally a delay buffer, it's actually a combination between single sample delays, and then each delay is being added back in. That's called an FIR filter. But anyway, basically what you do is you just line it up by delaying the whole smash so that it lines up with the woofer again. Mm-hmm. And now I hear some people wondering like why is that important? I've been listening to four-way speakers all my life and they sound fine. Well, I would ask the question then okay, why is it that if you go to a hi-fi show that in the same price bracket you can find one-way speakers like electrostats or broadband drivers, you can find two-way speakers,
Yep.
three-way, up to five-way, all in the same price bracket. Like, why is that? And there, the answer is simply that a one-way speaker is the only way you can get more or less time, more or less preserve the timing of a signal, at the expense, of course, of having to do a driver that will actually process all these, the entire audio band in one go, which is an enormous compromise. And then if you don't want to compromise on say distortion and power handling and so on, you have to start cutting in 2, 3, 4, 5 ways. So the absolutely most powerful passive speakers go up to 5 ways, because they can then play very loud, very cleanly, but not very timely. And in my experience, it actually depends on what style of music you listen to. Whether that is a problem or not, because, for instance, if you listen to orchestral music, and they've got a lot of reverb anyway, I mean, you don't actually get perfect timing even in the actual concert hall. You don't. Also, the musical timing. I mean, there's a reason why there's a conductor. It's because otherwise you get the trouble of these musicians trying to synchronize by ear over such large distances. So so timing is not ultra critical. But on the other hand, if you listen to, say, free jazz or classical music or Indian classical music, these guys and girls, they play with millisecond precision. And if you have a speaker that can show you that, where you can actually hear how precisely, a guitar is timed with a kick drum or something like that, something like that, then you appreciate that music at a much higher level. So that's why you typically find that people who use one-way, two-way speakers are typically jazz lovers, whereas classical music lovers tend to go for the bigger systems that have really the ampleur, as the French would say, of a big system. But it means you. Well, show me your speakers and I'll tell you what music you listen to. And so yes, people live with the speaker that they are used to, with the music that they are used to, and therefore might not be too much confronted with these drawbacks, but they are there, and especially once you start fishing in different ponds musically, you actually start appreciating that the timing aspect of certain types of music is absolutely critical. I mean, think about free jazz, in normal music, so to speak. What the composer will do is they'll set up harmonies and chord progressions and so on, and you make a mental prediction of what the next one will be, and the next one will be different, and so they create a tension and so on, and the whole thing builds up to a point which they call the resolve, where finally your expectations are being met in terms of harmony, and you get this emotional release of energy. Well, with free jazz, for instance, very often the melody is entirely incidental. It's sometimes you might recognize a couple of notes that resemble a song with the same name, but that's just thrown as a bone for people who don't get the idea, because the real idea is that these musicians are joshing with each other, playing behind the beat, playing before the beat, and they're constantly sort of building up a tension that way. And there is one particular moment where they just hit it all together perfectly. That's the release in that kind of music. And if you sit there listening to a 5-way system with that kind of music, you just don't get it. You just really don't hear it. You just ask like what on earth are these people on about? Yeah. And then you listen to an electrostat or a DSP corrected loudspeaker, and you go like, ah.
Yeah. Question. active loudspeakers, is there a revolution to be expected, or are we talking just more evolution in time?
I think the revolution is ongoing as active speakers are slowly more and more people are realizing that they actually can do things that the classic sound systems cannot do, and the more and more people realize that, the more and more active speakers are going to replace passives. Of course, it does require that the people who design active speakers actually use all the opportunities to make them better than passives. So it's because I've seen speakers in hi-fi shows where there's literally a sign next to it saying, "Do you want them active or passive? You choose." I've got like, well, what's the point? Whereas a fully developed active speaker is usually is visibly different. I mean, it's visibly much smaller for what it can do. So what you will see much smaller speakers suddenly turning up, doing things which bigger passive speakers can't even think of. And you will also start seeing yet more integration because once you've got a DSP in there, well, maybe not use a DSP, maybe just use a big general purpose processing chip like an ARM core. They can calculate fine. So you don't need a general purpose DSP chip, but then you've got something that you can actually run other software on at the same time, such as streaming software, internet radio, whatnot.
Yeah.
And so it's
more and more steps towards convenience.
More and more steps towards convenience, because I think we absolutely can get your average Joe to appreciate good sound quality, but they will only do so if it doesn't then destroy the rest of their lifestyle. I mean, and another thing which is not let's say universal to active speakers, but which has kind of become associated with active speakers is directivity control. So the reason for that is that at the same time that I put out the Key 3, it was also Dutch and Dutch. They came out with their cardioid speaker, and there was Bang & Olufsen with the BL-Up 90, which was not so much a cardioid as a speaker with programmable directivity in various ways. So because all these things happened at the same time, there is in the popular association an idea that active speakers and directivity control go together. Mm-hmm. I would say it makes it easier, but do keep in mind cardioid speakers have been built before. Actually, so for instance, the Finnish company Gradient has been making passive cardioid speakers forever. And I would say that we're ahead of their time, because I mean, you don't do cardioid for nothing. You do it because a speaker doesn't exist in isolation. No, you place it in a room. And again, if we go to your classic audiophile setup, you get the speaker standing very far into the room. Why is that? Is because they've gone looking for where to put the speaker so that the bass response in the room is as even as it possibly could be. Now there is an unfortunate confluence of that there, because you don't actually make the frequency response flatter by moving the speaker at that position. You can only make the smoothed, like the third octave smoothed frequency response. You can make that quite flat, but the actual frequency response always has these hard nulls in there. If you just turn smoothing off, you can't really see the forest for the trees. Mm-hmm. And what you actually find is the point where you get the smoothest, the flattest, smoothest response is actually one where those holes in the frequency band are spread out most evenly throughout the frequency range. which in turn means that you have spaced the timing of the echoes coming from all over the place to also in the most even way. So the exact spot where the third octave smooth frequency response is flattest is the spot where the time response is the worst. And that is kind of, again, a self-inflicted problem of standard loudspeaker design, because you think you're sitting in front of a loudspeaker, you think that the speaker is pointed at you. Well, the tweeter is, but the woofer will the sound that comes out of the woofer, that just bends around the cabinet. I mean, Christian Huygens figured that one out 500 years ago, so literally. So the result is that if you measure that speaker in an anechoic space, so in one of those big rooms with foam rubber sticking out of the walls, then actually all the sound that went round the cabinet and sort of found their way to the back, that sound doesn't find its way to the microphone. So you actually lose 6 decibels of frequency response. So you get this shelving type of response. That's sometimes called the baffle step. That shelving response. It's simply below that frequency, the speaker is actually pointed in all directions, and above that frequency, it's pointed at you. Mm-hmm. And so what they'll do is they say, okay, well, hey, so I have a flat frequency response anechoically, right? Because that's the ideal. So they'll add 6 decibels, or in reality, they actually take 6 decibels off the other part. Mm-hmm. But nevertheless, in order to have a flat frequency response in anechoic conditions, and but if you then take that that speaker into a live listening room again, then it means that you have twice the sound pressure pumping into the room at low frequencies, or even 4 times the power, if you like, and which rather makes it even harder to control. So it's just at the low frequencies where rooms are most difficult to control. That's where the speaker actually starts putting more energy out. So I would say that when people talk about baffle step correction, mm-hmm. If you're not a speaker designer, it sounds like some very arcane, very clever thing to do. But actually, no, it's not a problem corrected; it's a problem added, because you've actually added more bass where there shouldn't have been any. So what these newfangled cardioid active speakers like mine do is they essentially move that frequency where they start radiating in all directions, move that as low as possible, so that if you then move the speaker close to the wall, you don't get the frequency is so low that you don't get comb filtering from that wall reflection. Instead, you just get your 6 decibels reinforcement, which you just digitally remove, and you take it down by 6 decibels, and the result is in the exact same room, much less reverberant sound. So in the end, what we're seeing here is due to the bass cabinet design, transient response improves. Due to the crossover phase correction, transient response improves. Due to the fact that you can now use the speaker with the back against the wall, and reduce reverberant sound, you get better transient response. So those 3 items, and what we will see in the future is quite simply more and more people coming out with products like that, more and more people adding in further functionality until such point that it is now perfectly possible to buy a speaker that you just install in the room. You connect it to a power socket. You dial in your Wi-Fi password, and off it goes. And it sounds great. So what we're just going to see is that products like those will become more and more available. Again, thanks to the fact that the electronics is now affordable, and compact, and it can all go into one to one single case. So that revolution is happening as we speak.
Exciting times now and coming. So thanks for this one. It was a long one, but a very interesting one, talking about active speakers. Thanks for joining this Tech Talk. We'll see you in the next one.